Hey everyone, welcome to our presentation, A Byte of Binary. You can see the title, A Byte of Binary, is written in binary, which is what we are going to talk about today. I'm Serena Raso.
And I am Aine Holland. We are both software engineers at Rapid7, which is a cybersecurity company. In simple terms, that means that we work with and write code that helps protect our customers' information.
What is code? Code is a series of words, letters, and numbers working together to perform a function. Computer scientists may write what looks like modified English, as you can see in this image, but that is simply so us humans can understand what we're doing. Computers, on the other hand, are very stupid and don't understand those letters from words, let alone what either of those mean. But computers do understand numbers and math. So instead, we assign letters to numbers so that can translate our words to the computer.
But computers are even dumber than that, and they can't even count past 1. So instead, computers work and understand a language based on whether or not a signal is being sent. 0 means there is no signal, and 1 means there is a signal. So they only have 0 and 1. But how do you count to 2 when you only have 0 and 1?
Right, and how do you count to 10? The system we humans use to count is called the decimal system. Deci means 10, relating to the fact that we use 10 distinct symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Each of these numbers has a unique shape, and when we want to count higher, we simply repeat the shapes. 10 means we've gone through all of our symbols once, and then we don't go through those again, go up to another digit.
So using that idea, you can carry that over to binary. Bi means 2. So when you have 2 symbols, you need to repeat those symbols more often. So 0 is 0, 1 is 1, but 2 becomes 1, 0, repeating the symbols that we have.
A trick to understanding what any binary number is in decimal is to use powers of 2. We know 10 is equal to 2, and using, or 1, 0, which looks like 10, but 1, 0 is equal to 2, and using exponents, we can double proof this. So we have 0 times 2 to the 0th power, if you can see on that far right column. And we know 2 to the 0 is 1, and 0 times 1 is 0. And then we can do that again in that next column over, the 1 times 2 to the 1, 1 times 2, right? Because 2 to the 1 is 2. And we can keep repeating that process. And then all of those values we get underneath the line at the bottom, we just add those together. And then we know that that top value, that 1, 0, 1, 0, 1, 0, which is binary, is equal to 42 in decimal.
So now that we can count, what comes next is, of course, math. So you can do addition, subtraction, multiplication, division. Anything you can do with decimal numbers, you can do with binary. We're going to start with addition and subtraction because that's the simplest and the easiest to explain. And both are similar to regular decimal. For instance, adding 1, 0 plus 1, 0, or 2 plus 2, is very similar to normal math this way, only you have to carry the 1 much sooner, because 0 plus 0 is 0, but 1 plus 1, you can't use 2, so you need to bring that 1 to the next place over and carry it down. Similarly, if you have 1, 1, 1 plus 1, 1, 1, you have 1 plus 1, you can't write 2 again, so you do 0 and carry that 1 over. But then in this column, you have 1 plus 1. So you leave one of those ones behind that you carried over and bring that 1 over, and so on. That way you get 7 plus 7 is 14, which is also 1, 1, 1 plus 1, 1, 1 is equal to 1, 1, 1, 0.
Yes, and then we have subtraction as well. And looking at that first, 1, 0 minus 1, 0, well, we know 1, 0 is 2. And if we do 0 minus 0 in that first column there, ignoring the 2's for a second because that's in decimal, The 0 minus 0 is 0, and then 1 minus 1 is 0. So that's a very simple problem. Then we go to the next problem, and if we start in that ones column, the 0 minus 1, we realize that we can't take away from nothing, right? So we have to go and steal a 1 from the next highest place, which in this case is the next column over has a 1. So we take that 1 becomes a 0, and we bring that 1 over. So it becomes 1 0, and that 1 0, which we know is 2 in decimal, subtract 1 from that, and you get 1 in that first ones place column. And then we go to the next column. We know that's no longer 1 anymore. It's a 0. So 0 minus 0 in the tens column is 0. And then 1 minus 0 in the next column over, hundreds column, is 1. And then 1 minus 1 is 0. And then 1 minus 0 is 1. So the only kind of tricky part of this was that first column, the ones column, where you had a 0 and you're taking away from nothing. But now you have this binary value 10101, which translates to 21 in decimal, and we know that's correct because 30 minus 9 is 21.
But guess what? There's not just binary and decimal. There's many ways to count, including my favorite, which is hexadecimal, or counting using 16 signals. So once you get to 9, you start using A, B, C, D, E, F, and G. But don't worry, that's a different STEM bite. We're not covering that here.
Awesome. Thank you for watching. Learning binary is as easy as 1, 2, 3, or 0, 1, 1, 0, and 1, 1.